Hi, my name is Łukasz Górnicki. I'm an AsyncAPI maintainer and a community guardian. And today I'm going to talk to you about AsyncAPI and WebSocket, but I choose WebSocket as an example here because that's easier to explain. If you're not using WebSocket in your company, in your architecture, that's just fine. Whatever you're going to see today actually can be applied to any event-driven architecture. So later on, if you want to ask more questions and you're afraid to ask them in public, you can grab my personal contacts. You can write some private message if you want, direct message. I answer all the inquiries, so no worries. Feel free to contact me. Now, today the plan is to talk about 4 things. First of all, introduce you to AsyncAPI specification and AsyncAPI initiative. Then I will have to do some intro to WebSocket anyway, if we want to continue around the WebSocket topic. Then I'm gonna tell you like what the spec and the event-driven architectures have to do with each other. What's the point of using both? And in the end, some live coding. So yeah, first, specification, AsyncAPI. So the goal of AsyncAPI is to use it, for example, when you have event-driven microservices. You've got some Kafka message broker, somewhere in the middle, bunch of services that talk to each other through the message broker. That's the moment where you would use AsyncAPI. Another use case, Internet of Things. Most probably you've got a MQTT broker that collects messages from all your devices and then makes them available for consumption for your services. Another use case, streaming API. So let's say Twitter, you've got, or Facebook, you've got a browser, you want to see a feed that refreshes every second with all new things showing up. That's where you need a message-based stream. So all those 3 use cases, what they have in common is events, messages. So yeah, AsyncAPI spec can be used whenever there is a need of handling messages in your system. Everything is based on events. The cool stuff is that if you noticed, I mentioned like 3 different protocols. I talked about Kafka, I talked about MQTT. This talk is about WebSocket. And the cool stuff about AsyncAPI is that it's protocol agnostic. So you've got a core of the spec that you can use to describe your application, but you also have a feature called bindings. So you can describe additional protocol-specific information with your specification for example, Kafka or MQTT. Now, AsyncAPI is a spec, but there's also AsyncAPI initiative. What they have to do in common. So AsyncAPI initiative is a initiative that takes care of the spec. But what is differentiating us from other initiatives like that or other open source organizations is that we treat equally important not only just the spec, but also the tooling for the spec. So we truly believe here that users should not only get a specification from us with latest improvements, but at the same time, we should also deliver basic tooling. So you can use from day one the spec with your tools. You don't have to wait for vendors to update or any other tooling providers, because the initiative feels responsible for making sure that tools work properly with the specification. And we provide like variety of tools, docs and code generators, like parser of the AsyncAPI documents, UI and CLI, everything focused on making it super easy to work with the spec. Now, the spec and tools, they're adopted by many companies. The challenge with event-driven architecture is that in many cases they're private, which means people, they don't talk about it that often as with the public interfaces. So we always have to do a bit of spying and a lot of asking and discussions with different people to learn who uses AsyncAPI. But we already managed to learn that much, and we always encourage people to come to us and tell us like that you use this spec and how you do it, how do you use our tools. Now, if it comes to the latest history of the spec and the initiative, last year and this year it's super active. So Rapid API and their developer survey showed that AsyncAPI grew in adoption the most among the other specs by 3 times in production. ThoughtWorks put us on their technology radar as a point to assess in the future. And InfoQ last year put us on their innovators place, and this year or on early adopters, which basically, to summarize, means if you're not yet using AsyncAPI, you should definitely try it out and see what it can do for you. As a result of all those activities, like a lot of work that has to be done in the spec and tools, the community that we've built around, the adoption of so many different companies, a lot of corporations as well that care about who's owning the project. For us, natural next step was joining Linux Foundation as an open source organization, and that happened at the end of March this year. So that's pretty much nicely summarizes the activities around the project and the stage where we are. So we're pretty hyped now, and if you were looking for some cool open source project to join this year, I think AsyncAPI is a good candidate for that. Now, enough spec, WebSocket. I'm gonna cover basics, so sorry for that, but I'm gonna base the basics on my experience. So when I heard about WebSocket first time, I think it was 6-7 years ago, it was related to my work on a building UI. I had a front end and I wanted to build a really nice experience for the user, so they can see real-time data updated in the browser without a need of browser refresh. And that was the main use case and most common use case for WebSocket. So you've got a server with WebSocket API, and you've got a browser, a client, where you can open a single connection with the server, bidirectional, so you can send messages from the browser to the server, and also there's a stream of messages coming from the server, so we can really real-time update the user interface and show the changes to the user. But that's not the only use case. One of the recent most known use cases is cryptocurrency trackers. So, cryptocurrencies, they're pretty hype these years, and they're the values are changing pretty rapidly in cryptocurrency. So you need a way to get access to the latest information about the value of the cryptocurrency, really in real time, like every second latest price. And to be able to do it, what was chosen by devs was the WebSocket API. So all those trackers, they expose WebSocket API, where you can, again, consume data in a browser or on other server and react to the latest information about the prices. Now, looking from a different perspective, cartoon perspective, on the architecture of WebSocket is when you try to compare it to polling, HTTP polling. So basically, if you want to have nice UI interface that refreshes without manual browser refresh, in the background you have to have some logic that uses REST API and every few seconds tries to get to fetch the latest information from the API. Not so cool, like if you remember the scene from Shrek about Donkey asking all the time the same question, are we there yet? Are we there yet? That can be annoying. And yeah, I mean, you have to open the connection with the server every time you do it. What's the point if you have WebSocket, where you can just open one connection and ask for the updates? And then the updates are regularly delivered to you whenever something changes in the system. You don't have to ping the system all the time. And it's pretty nifty and have a variety of use cases. What they have in common, like Spec and WebSocket, I mean Spec, right? So Spec, what can you use Spec for? You write the YAML or JSON file and then generate docs with it. And that's it. And I'm afraid that many people just do it for that purpose. And I personally feel sorry for such approach, because first of all, sorry for me and other maintainers of the AsyncAPI, because like putting so much effort into the spec, into a machine readable format that you can really consume in many different ways in your system, and doing it only to generate docs. And don't get me wrong, I mean, I'm coming from a technical writing background, so I love docs and I think they are super important. But if you write a spec that is machine readable, you describe, for example, a message that user can send to the system, and you provide a schema for the message. Why just showing it as a part of documentation? Why not using it to generate some code? Why not using it to do a real-time validation of the messages coming to the service? Why not do all those different things for testing, mocking? So reusing one content for many different use cases. And that's going to be my goal now. So enough slides for now. I'm going to jump into a live coding session, and I'm going to show you a AsyncAPI generator in action. So I'm going to do some code generation. But yeah, let me quit slides and open Visual Studio Code. So what you can see here on the screen is my face. I'm going to move my face somewhere so it's not disturbing anymore. So you can see I have an empty project with just a single YAML file, which is called Shrek YAML. And I'm going to use the opportunity to say hello to all YAML developers around Kubernetes project. Enough jokes. So Shrek and the structure of the document. So what I did before the presentation, I designed my Shrek application using AsyncAPI. So what I did, I provided one of the main core objects in the spec, which is info, with basic information about the application. Also servers, another main part of the spec, where you can specify many different servers like staging, production. In my case, it's just one server called Swamp that you can connect with on localhost with WebSocket. Now, channels is the place where you specify all the different connection points with the WebSocket API in this case. So I have a channel that can accept messages and also publishes messages. They all look the same, and it's purely for chat discussion. Travel status is where you just subscribe to get messages. So you basically just establish a connection with the channel, and then get a stream of messages. Now, the last part of the document is components. It's mainly for reuse purposes and to make the document much cleaner. So you can see here, for example, it's much cleaner to read channels, to see the operations you can do with the channel, and the details about the message, they're just in the components. So you can see the chat message is just a simple string. In case of travel info, it's a bit more complicated schema with 3 different properties, but you can present them with a nice example of the payload. So as simple as that, 70 lines. So I have an interface of my application. What you should notice is that I'm writing always one AsyncAPI document per application, and I write it from a user perspective. So as the user is reading it. Meaning that when, for example, travel status has an operation subscribe, it doesn't mean that my Shrek app is subscribing to this channel. It means that user can subscribe to this channel. So I'm publishing messages. Okay, so let's for now just close this file, bring up the terminal, and yeah, let's do some first generation. So I've got a AG is AsyncAPI generator installed. Shrek is the YAML file I just showed you, and AsyncAPI HTML template is one of the templates that we can consume within our AsyncAPI generator. And I'm gonna generate a HTML to the docs folder. It's gonna show up here. It's here. Let's wait a second for generation to be finished. Okay, and let's see in the browser how it looks like. Okay, success, full success. We've got docs generated. We see that we can publish and have subscribe to two different information from the API. We know what server to connect with, how the payload looks like, what's the example of the payload, like pretty nifty. But again, as I said, that should not be just that. We should do a bit more, right? I mean, what was the effort worth? So let's generate some code. Again, AsyncAPI generator, Shrek YAML file, and another template, not HTML template, but Node.js WebSocket template. And I'm gonna put it in different folder. And what I have to specify is what server I want to use during the generation, because I can have two different servers and of course two different connection points. Sometimes they can be different. So that's why I have to specify the server. And I have one, just so let's choose Swamp. And the generated project will be like full-blown project that I can, yeah, just put only the business logic in. So let's do some quick walkthrough the generated code. So my app got many different files, but the core is in the API. So routes, you can see that two routers got generated. So we're gonna listen to any connection to chat and any connection to travel status. So you recall those channels from the file. And yeah, important to have a look here. So whenever there will be a connection to chat, some subchat message will be called. Then whenever message will be sent to this chat, again, another function will be called. In case of travel status, there's just, if you recall, this channel can only, the application publishes to the channel, so user can only listen to the messages. So only on a connection, subtravel info function is going to be called. So far, so good. So let's see those functions. So we have two services generated for chat channel and travel status. Travel status has just this one function with some placeholder that we should replace. And chat, because it had two operations, subscribe and publish, it has two different functions with also placeholders. And what we're gonna do here is we're just gonna replace the logic here in those generated functions. Okay, so let's go back to the app and let's install it first, right? So let's go to the app. It's Node.js, so npm install. Now, my use case is travel status has to send messages. Of course, I don't have information about any real travel, so I'm gonna have to mock this data, and I'm gonna use some package for it. And in case of chat, I actually set it up a real chatbot that I trained with AI. And to talk to this REST API of the chatbot, I'm gonna have to use the node fetch package. This means that I have to additionally install two dependencies for my application. So it's node fetch and dummy JSON. Okay, once I install them, I can jump into the writing some code, and let's start with chat. Let's lower the terminal again. First of all, with chat, I'm gonna have to talk to REST API of a real chatbot. So I need to have some tokens. So that's why here I'm importing the configuration from the project. Of course, as you recall, I didn't yet configure anything there, but bear with me. And another package that I need to import here is, of course, this node fetch. Now the business logic, I have, of course, everything prepared up front, except of sub chat message. So that's the message that will be sent to the client once the client connects with the chat. So so let's just send to the user welcome to Shrek chat whenever the user connects. And in case of reacting to the messages sent by the client, let me paste some logic here. So to not bore you with the Node.js code, the most important to notice is here. So once we get a message from the client, the server forwards the message to the with AI interface with the token that we will soon provide. And then, of course, the chatbot replies, and this bot answer is later on sent back to the client, and it's also logged in the console log, so we can see that it really happens on the server side. Okay, that's it. If it comes to the chat now, travel status. Here we need to import the dummy JSON. That's a package that I use to to mock the JSON with those three different properties like destination, arrival time, etc. And again, we're gonna replace the existing placeholder, put some logic here, super simple logic. So a loop that every second 100 times in row will send a generated response, which is a object with destination, arrival, distance generated with dummy JSON. Almost that, of course. I have to provide the token. Now you should now close your eyes. No, you don't have to close your eyes. No worries. I'm gonna show you that I actually do it real time. So I'm gonna paste a token here. And I know it's bad practice. You should not do it alone at home. I'm doing it because I have this luxury that right after the recording, I can actually regenerate the token. So that's why I'm so smart here. Okay, everything is ready. Everything is in place. Let's start the server. npm start. So far so good, listening on port 80. Now on the left side you see the started server, and now on the other terminal I'm gonna talk to the server from the client side. I'm gonna use a tool called WebSocket, which is like curl for REST API, but WebSocket is for WebSocket. And I'm gonna connect with a localhost server. So you see this information that I could read from the AsyncAPI file, and the chat channel. After connection, I got answer from the server, welcome to the Shrek chat, and the client got connected. So far so good. So yeah, let's write something like, "Hi Shrek. Hey, do you know ogres have layers? Layers of onion?" No, it is not a donkey. Hey, come on. Stop calling donkey. Okay, so far so good. How is Fiona doing? Ooh, that's hard. And what about donkey? How is he? Yeah, that's something that will pretty soon happen to Fran too. So anyway, that's the discussion with the chat bot. That's the client part. This is the server, so you could see every time the message was received, it went to the server, it was logged, and the answer was also logged. So it was a pure communication between client and the server. The cool stuff about the code generation is that you don't only generate server, you can also generate client. So you don't have to use, for example, WebSocket. And that's what we're gonna do when we will play with the other channel. So let's have a look again on the generated project. Except of SRC, we also generated super simple, like really super simple primitive index HTML with some basic API to talk to the server as a client. You can see that during the generation, we took information from the server section of the spec. So yeah, let us open up the index file in the browser. Okay, so we disconnected from the channel and open. Okay, so as you can see, it's pretty primitive, nothing in the UI, just information to open the console of the browser. Still, it's a client. We have some docs generated, so we know what channels we can connect with, and we'll connect with travel status. So listen. And what will happen now, I'm gonna hit enter, and we're gonna see a stream of events sent from the server every second with some different travel information. Okay, and as you can see, the messages are coming. So some generated data every second, 100 times in a row, will come from the server. So to summarize, with one AsyncAPI document, I was able to, first of all, generate documentation. But again, that's not the only use case. I was also able to generate the server and the client and just focus on putting some business logic. And that's it. And there are more use cases, like testing of this application. Or I could have a real-time validation of the messages. So for example, in the chat, if I would try to send something different, like a JSON, for example, instead of string, I could validate it on the server side and say, okay, message not accepted, and reply back to the client, like message is wrong or something like this. So there are many, many different use cases, and you should definitely explore all of them. So back to the last slide, like the goodbye slide. So if you got interested with the topic, I definitely encourage you to explore more about AsyncAPI. It's a pretty big topic with many different interesting use cases, many different tools already in with major release, many tools in the pipeline to deliver. We're looking a lot of for many people to support us and help us out. So I hope that after this call, we're gonna see each other again on the Slack workspace. That's it, and thanks for watching and listening. Cheers.